Good day, learners, once again. So today we'll be looking at preparatory examination 2022 Geography Paper 1, which includes climate and weather and geomorphology. Our question today, we are starting with question 1, which is climate and weather, and below are the questions. All right, so question 1.1.1. The slope dash is the angle at which the sun's rays strike a slope. So for this, it's supposed to be option number B, which is the aspect. Because as we know, the side which a slope faces, that side receives direct or receives more heat compared to the other side which doesn't receive the direct heat. So therefore, the slope aspect is the angle at which the sun's rays strike a slope. Right. 1.1.2, in the southern hemisphere, the dash facing slope of a valley receives the most sunlight. We are in the southern hemisphere. If I try to do this one quickly here, this is, sorry, that's a sketch. This is the southern hemisphere here. This is our slope. We have the north, we have the south. And we know this is the sun, which gives direct heat. So they say direct heat. That's why this side is going to be more warmer. The north facing side will be warmer and the south facing will be cooler. So we go back to the question. The southern hemisphere, the facing slope of a valley receives the most sunlight, which will be the north facing side. For this case, answer will be A. 1.1.3, in the southern hemisphere, the dash in a valley is the south facing slope. In the southern hemisphere, once again, so that will be the shadow zone. The shadow zone in the southern hemisphere, the shadow zone in a valley is the south facing slope. What does that mean? It means that the shadow zone is being obstructed or does not receive direct heat. Therefore, it will have shade, or that side will be a bit much more cooler. That is why we say in the southern hemisphere, the valley will be the shadow zone. 1.1.4, katabatic winds occur at night due to terrestrial dash from the valley slopes. All of us know that during the night, the land loses heat through a process called terrestrial radiation, where the land loses the heat. This is one of the reasons why at night we do cover ourselves with blankets, because the temperatures seems to drop. When they drop, that means the heat, or sorry, the land is losing the heat through a process referred to as terrestrial radiation. Number 5, a temperature inversion occurs when a layer of cold air develops a layer of warm air. And all of us know, whenever we talk about inversion, so that is a point where temperatures increases with height. Now, when they say a temperature inversion occurs when a layer of cold air develops a layer of warm air. So this is gonna be beneath. So a layer of cold air develops beneath a layer of warm air. So something like this. This is the cold air. Yeah, this is cold air. Then here we have the warm air. The warm air which forms our inversion. So that's why we say cold air develops beneath the layer of warm air. Number 6, is stroke are most likely to occur on the valley floor during winter. So on the valley floor during winter, they will form frost pockets. in a valley. Like this, we know that whenever cold air subsides in the valley bottom, so it's going to collect at the bottom here, forming our frost pockets. All right, let's continue to question 1.1.7. Radiation fog in a valley is formed by the process of condensation of water vapor. Okay, so this occurs, we know condensation is a process whereby vapor changes into liquid again. So as air subsides to the valley bottom, this air is going to change from being vapor to liquid again, resulting into formation of radiation fog. But the process that results into that will be condensation, a process whereby water changes from gas to liquid. Okay, so that is question 1.1. Let us proceed to question 1.2, which says, study the figure below based on a cross-section of a tropical cyclone in the southern hemisphere. All right, this is our tropical cyclone. As you can see, it's being labeled A, there is C there. Can't see other labels, but we shall see what to do. All right. Question 1.2.1, it says, indicate the season in which this tropical cyclone could occur. And we know that tropical cyclones, they usually develop, we could say, late summer. That is when the temperatures are way very high. We could say late summer or early autumn. Okay, early autumn. Yeah, this is when temperatures are very high to result into the development of a low pressure. So sometimes we avoid just saying summer because it is just summer. When summer is just starting, at times temperatures are very low. So that is why we prefer saying late summer or early autumn. That is when temperatures are way high to support the development of a tropical cyclone. Again, 1.2.2, it says, state the minimum ocean temperature required for the formation of this cyclone. And we know the cyclones, they require 26.5 degrees Celsius or 27 degrees Celsius. So those are the minimum temperatures that are required. When we say minimum, it means we can't go below that one. So it is from 26.5 going upwards. All right. 1.2.3, in which general direction would this tropical cyclone move? We know cyclones, they always move from, that's going to be east to west. Or we can as well say westerly direction. And I believe you know the reason for this, because they are driven by easterly winds. That's why they move from east to west, or they move to the west or westerly direction. Okay. 1.2.4, it says, name the cloud type found at A. This is at A here. This is at A. And you can see these clouds are huge and tall. All right. Now, what is the name of those clouds? And we know clouds are categorized into different. We have the cirrus, we have the nimbus, and all that. So, however, the huge and tall clouds are referred to as the cumulonimbus clouds. Cumulonimbus. The cumulonimbus clouds. Okay. Now, question 1.2.5, it says, state the precipitation likely to occur from cloud type A. Now, we know that the cumulonimbus clouds are associated with heavy rainfalls. I would say heavy rainfalls. Heavy rainfalls. We could say torrential rainfalls. Torrential rainfalls. We could say thunderstorm showers. Thunderstorm showers. Not showers, supposed to be showers. Thunderstorm showers, etc. So basically, we say heavy rainfalls, torrential rainfalls, or stroke thunderstorm showers. Okay. Question 1.2.6, is the air surface pressure at area C low or high? The air surface pressure at C, is it low or is it high? Let's go and look at C. So we are here. This is point C here. They're saying, is the air pressure at this point high or low? I think the first concept, we need to know that at this point, at point C, we see air converging, converging, air moves towards the same point. After converging, then it rises. Now, the mere fact that air rises, it means when air moves away from this point, a low pressure is going to develop. So that is why we say the pressure at C will be low pressure due to air rising or ascending at that particular point after converging. 1.2.7, would the airflow at C be described as diverging or converging? And I think I just explained that one in the previous question. So they're saying, would air flow at sea be described as diverging or converging? So remember, to diverge is when air moves away. It is to diverge, and to converge is when air moves towards the same point. So this is to converge. Now, if we check point C, if we check at point C, you can see that this is our air with black arrows indicating air moving towards this same point C, which means for our answer would be converging for question 1.2.7. All right. 1.2.8, at what stage of development will this tropical cyclone be when it moves over land? And all of us know that whenever cyclones move towards land over the land, it means they will lose their energy. There will be less latent heat, times cooler conditions, inflow of dry air, which means the cyclone will be in its dissipating stage. We could say dissipating, or decaying, or degenerating stage. Okay, so this is when they say it moves over the land, it's like the cyclone has reached the land. Whenever it reaches the land, there is friction. That means there will be less light and heat, less evaporation and condensation, which does affect its strength and as well making it to weaken, and eventually it will dissipate. All right. Let us proceed to the next question, which says 1.3, for the infographic showing bare wind conditions over South Africa. Okay, so you can see this is our infograph. I see the map of South Africa here. this other written information on this other side. We have a graph here. So remember, whenever we talk about infographs, like it is information in form of graphic, which could be maps, charts, articles, and all that. So that is all about when we say infograph. All right. Let us try to look at the first question. They say, which season is being depicted in the diagram? Let's go back to our diagram. Which season? So this is going to be winter season. It's going to be winter season. We shall see, since they are already asking us to give evidence. So this is winter season. Now they say, provide evidence from the infographic to substantiate your answer to question 1.3.1. So we need to provide evidence from the infograph. So it means whatever we are going to give, it must be gotten from the infograph. All right, let's go to the infograph to try to see or to show why we are saying this is winter season. Okay. Firstly, you can see that the high pressure cell is dominating the interior. You see, the learners. So whenever you see this HH, it represents a high pressure, and that means it is dominating the land in winter. So this is typical of winter conditions. So we could say presence of the high pressure, presence of a high pressure dominating the interior. That is one evidence. As well, we can look for other evidences. Look at the position of the mid-latitude cyclone. See where it is positioned. It means it has moved all the way from the southern and it moved to the northern area. That's why it was able to influence South Africa. So this usually happens in winter. So we see the cold front. I think let us try to use our blank page here. Check here, check here. Okay. All right, we are there. Question, that was question 1.3.2. Yes, so we said there is a high pressure cell over the land or dominating the land. Second, we said the cold front or mid-latitude cyclone has moved further northwards over the land. So let's check again for clarity. So you can see, like we mentioned, the cold front has moved further northwards over the land. Another evidence, we could as well look at the position of the high pressure cell. You see, this high pressure cell that we refer to as the Indian high pressure cell, it has well moved northwards. Normally, these high pressure cells in summer, they are situated a bit further away. Could be somewhere here. The MLC or the mid-latitude cyclone could be somewhere here in summer. Okay. Then in winter, they move in that direction. They move northwards, close or towards the land. So that's why we are saying we're now seeing the mid-latitude cyclone over the land here. We see the South Indian high pressure cell, which as well moved northwards over the land. Okay. So that's why we say, you could as well say the South Indian high pressure cell has moved further north. Okay, let's try to check the other evidences. We could as well talk about the big wind conditions. You can see this. This is a coastal low. This is a high pressure cell. So it means there's a pressure gradient here, meaning winds will be moving from the high pressure cell, the low pressure cell, high pressure over the interior to the low pressure cell over the coast, resulting into a development of the big wind condition. So we know that big winds as well develop during winter. So you could say there are big winds or big wind. Yes, so wind is fine. Big wind conditions which occur in winter. All right, dear learners. So that is for question 1.3. It's true. Okay. Let us proceed. Okay. So question 1.3.3 says, state two atmospheric conditions evident in the infographic that have resulted in the formation of big winds. Like I think we saw this in the previous question. They're asking what conditions does result in the development of formation of the big winds. All right, like we mentioned before, you can see move it. Okay, so you can see the big winds to develop mainly they must be a high pressure cell over the interior and a low pressure cell over the coast. So with this, there is a pressure gradient. That is why we say one of the condition there must be a pressure gradient as our factor. The first one, pressure gradient. What is pressure gradient? It refers to where one area, or it refers to where the pressure is different between different places. That is, for example, here you see we have a high pressure over the interior and a low pressure over the coast. So this is what we refer to as pressure gradient. So this will hence result in the development of the winds, because we know that always winds they move from a high pressure going to the low pressure. All right, so that is why we are going to say that there will be formation of big winds as a result of the pressure gradient. Secondly, we can as well talk about the high pressure cell over interior. Okay, as you can see here, this is our high pressure cell, which is the Kalahari high. So you can as well just say this Kalahari high pressure. Okay, or another factor, another condition, we're going to talk about the coastal low. The coastal low pressure cell, which is situated along the coast. So this is our coastal low pressure cell. This one here would be our coastal low. So because of the presence of the high pressure cell, like we've mentioned, the high pressure cell over the interior, the coastal low over the coast, the pressure gradient. So this does result in the development of the big wind conditions. Okay, 1.3.4, with reference to the temperature graph, explain the process of temperature change from 3 to 2 as big winds blow from the interior to the coast. So we need to look at the graph and try to explain what is happening regarding the temperature. So let's see the question once again. It says, with reference to the temperature graph, explain the process of temperature change from 0315 to 1400 as big winds blow from the interior to the coast. All right, let's check the graph here. They said from 0315, and as you can see, this is our temperature graph here. So this is this line of, let me say this is the vertical line, which could be the longitude for that case. Then this is 315 somewhere here. Then they said from 315 all the way to 14. But you can see, imagine that it is you are here. It means I am climbing vertically. I keep on climbing. I climb. At this point, then I go down again. See, I continue to go down. You see this. So if it is with temperature, of course, this shows that at 3, the temperature started to rise. They kept on rising. You see, because you can see here, they were somewhere in 20 degrees C. They went to 25 degrees C. They went to 30 degrees C. They went to 35 degrees C. They went to 38. They reached 40 degrees. You see? Then again, at around 10, then they dropped. There's a sharp drop. Then here there was a gradual drop, you see, to 2 o'clock. So we are going to say, with the reference, let's use our blank page. This question 1.3.4. That T14, 15, the temperatures were rising. And this was due to the incoming hot winds. Okay, let's check again. So like we mentioned, try to remove this. So we not to, we said at the 0315, not 2. It's supposed to be 0315. Sorry about that. It should be. This is 0315, right? 0315, temperatures were rising. Well, let's hear the question once again. With reference to temperature graph, explain the process of temperature change. I want us to explain why temperature was able to change from this to this. You see? And that's why here we said temperatures were rising, and this was due to the incoming hot winds. which are the big winds. And as well, we could say the temperatures kept rising. Temperatures kept rising as a result of a diabetic descending wind. So meaning that as winds were subsiding from the interior to the coast, they were warming up and drying up, therefore resulting into temperatures to keep on rising. Then we say somewhere we see the temperatures dropping. So you can see that again, from this is 10, right? From 10 to 14, there was a sharp decrease in the temperatures. So you could say 10 a.m. to 14 p.m. there was a drop in the temperatures. There's a drop in the temperatures. All right. Okay. Let's go back to our page. So now that was question 1.3.4. 1.3.5, they say the weather station located at A has reported clear skies. Account for this current condition. A weather station at A has reported clear skies. Let's look for point A. Okay, point A. So this is our point A here. That along this area there are clear skies. So when they say clear skies, it means there are less few or there are no clouds that are developed along point A. And this could be as well. Let's go to our blank page for question 1.3.5. 1.3.5 could say clear skies due to dry or hot winds resulting into less condensation. Remember, when air is dry, it means it will have low humidity, making or resulting into less condensation to take place, giving us clear skies. And secondly, could say as well subsiding air, subsiding hot dry air at point A results into clear sky. So we know that whenever air subsides, if I can illustrate it here, whenever air is subsiding, it means there will be no condensation here to happen. That means we're going to end up having clear skies. But whenever air rises, like for this case, if air rises, it means there will be condensation resulting into formation of clouds. So where there are big winds, it means there are clear skies as a result of dry hot air or subsiding hot air. You see, that's why at point A it will have clear skies. 1.3.6, it says, explain why city A, which is situated on the east coast, will be affected by the rise of fire warning. Explain why city A. Let's go check city A. Okay. So city A here, which could be Durban for our case. Durban. So this is Durban here at A. And they're saying, explain why city A, which is situated on the east coast, will be affected by the release of fire warning. Why are they going to issue fire warnings at city A? That is what the question wants us to talk about. Okay, let's go back to our blank page. Okay. Okay. Why are they going to issue fire warnings at city A? One, we could say to alert people at city A to be aware of the fire outbreak. Two, to ensure that people can evacuate away from that area. Another reason why they issue warnings there, to make sure, to ensure that people are not at risk of fire. So could say save lives. So they're going to issue warning to save lives for both people and animals. So to ensure that people do not do bush burning during big winds. As well say to ensure that people stock enough water in case of dehydration, among other reasons. So that is why they are issuing warnings at city A, is to ensure all those factors and as well to make sure that people are safe. All right. So that was question 1.3.6. Let's proceed to question 1.4. It says, refer to the infographic below on mid-latitude cyclones. Okay. As you can see, that is somewhere here we can see the mid-latitude cyclones here. There's some this other side. And see the map of Southern Africa here. You can see Madagascar. See, There's the high pressure cell here. There's another on this other side. So like these are MLC, of course, they are low pressure cells. These are isobars. You can see in steep pressure gradient here. Okay, so there's a stationary model here. So always try to analyze the infographics, and as well you read the information that is indicated. Okay, so let's go straight to the questions. 1.4.1, it says, what climatological evidence indicates that this mid-latitude cyclones is occurring in the southern hemisphere? Okay, what do we look at to ensure that this mid-latitude cyclone is situated or occurring in the southern hemisphere? Right. Firstly, we can look at the date. First, move all this, make it look more clearer. Okay, so you can see the date. Our date here is 9 June. And all of us know that 9 June, this usually happens in winter. You see, 9 June in the southern hemisphere, it is winter season. This is when temperatures are very, very low. So one evidence to prove that this mid-latitude cyclone is in the southern hemisphere is by the mere date of winter. So the date showing winter in the southern hemisphere. So that's showing winter in the southern hemisphere because winter in the southern hemisphere that starts somewhere from May towards May, June, July, August. Yeah, that is plus still in winter season. So if we see June and we know that this is winter, and this must be in the southern hemisphere. What other evidence? That was for 1.4.1. 1.4.1, we said that which shows winter in the southern hemisphere. Okay, which other evidence? Let's check. We can as well talk about the position of the mid-latitude cyclone. So you can see that they have moved further northwards. You see, this normally occur in winter. So the position of mid-latitude cyclone further north. See, and this occurs in winter. Let's go back to check again. So like I mentioned, sorry about that. Erase that, remove all this. Like I mentioned, in winter season, the mid-latitude cyclone is always situated further northwards. See, they are moving further northwards, which is typical of winter, but in the southern hemisphere. Okay. Because we know that in the southern hemisphere, mid-latitude cyclones will be situated further northwards. So what other evidence can we give to prove that this is southern hemisphere? Remember, We need to be very careful with this question. It talks about climatological. Okay, wait for my pen to react. Okay. It's technology sometimes. So just to recap, we said 1.4.3, the stage was the mature stage. 1.4.4, the cross section, like we showed it here. This is the cold front, this is the cold sector, this is the warm sector. Then for 1.4.5, a group of tourists want to attempt the hiking trek to the top of the Table Mountain ahead of the cold front. And they're saying in a paragraph, approximately 8 lines, advise the organizers of the hike why the event should be postponed by explaining the expected conditions and possible impacts thereof. Okay, 1.4.5. So we need to look at the possible conditions and the impacts thereof. All right. Let's do like this. Sorry. Okay. So ahead of the cold front, we're going to say, because there will be overcast clouds starting into poor visibility. When it's too dark, it means the tourists might not be able to see properly. As well say, the cold front lowers temperatures, making the area too cold and unbearable. Because whenever there is a cold front, temperatures will drop. You need to be very, very cold. And as well say, tourists might catch flu or cold due to very low temperatures. The area will experience, resulting into poor visibility. As well say, there will be heavy rainfalls. There will be heavy rainfalls. Which could trigger landslides or mudslides as well. heavy rainfalls. Heavy rainfalls could result into floods. Which might impact on tourists. I can as well say transport and communication. Transport and communication will be disrupted, which could result into tourists getting lost. So among other factors. So just to recap, we said there will be overcast clouds resulting into poor visibility. The cold front makes temperatures to be very low and unbearable. Tourists might catch flu or cold due to very low temperatures or due to cold snaps. And the area will experience snow resulting into poor visibility as well. There will be heavy rainfalls, which could trigger landslides or mudslides. Heavy rainfalls could result into floods, which might affect on tourists. Transport and communication will be disrupted, which could result into tourists getting lost, among other factors. All right. So that is for that question. Let's proceed to question 1.5. 1.5. Okay. Refer to figure 1.5 below, showing a pollution dome. Excuse me. So they say define the term a pollution dome. So you could say a mass of polluted air, above the city. That's the pollution dome. As you can see here, this is the city. So you can see pollution taking place here. So all this now is a dome which has formed as a result of trapped pollutants in the warm or in the heat island, resulting into a pollution dome. So that is why we define it as a mass or a lot of polluted air above the city. Okay. 1.5.2, they say at night, the pollution dome is lower in elevation than during the day. Explain why this occurs. At night, the pollution dome is lower in elevation than during daytime. So explain why this occurs. Okay. So we're going to look at, let us try to use the blank page to illustrate the two. So this is a pollution dome at night. This is our step, for example. It's our city with tall buildings. This could be the CBD in the center. Then during day, so you can see the elevation at this one. During daytime, the pollution dome is way above the city, you see? But at night, it is way close to the city. You see? So what causes this? Why is it that during day, the pollution dome is way far away from the city, then at night is much more closer to the city? What could be the cause of this? Okay, so that's what we need to answer. Okay, let's look at the answers here. We could say that at night, due to terrestrial radiation, this is when the land loses the heat due to terrestrial radiation. The dome subsides close to the city. So at night, we know temperatures are low. Therefore, the dome cannot expand upwards. Instead, it will be contracting, moving towards the city or towards the surface as a result of cooler conditions. Secondly, at night, there is less convection currents. Less convection currents resulting into the dome to move close to the city. Okay. At night, we could as well say at night, there is a lot of pollution, trapped in the air. Okay. So, so far, those are some of the reasons. Okay. As well say at night, there is a lot of subsiding air, pushing the dome downwards. Okay. Let's go to question 1.5.3. They say, state the environmental problem that results from a pollution dome which develops close to the surface in a city. Environmental problem. As well we know, there might be acid as the rain would form. As the rain could form, and as well, we'll talk about the heat island, poor air quality. Okay, so there could be a formation of as the rain, development of heat islands, or poor air quality. Okay. 154. Describe how the environmental problem identified in the above question develops. Let's go to 154. Let's use our blank page. 154. About as the rain. could form due to the reaction of water, gases, and pollutants above the city. So when those mix up, the chances of experiencing acid rain will be high. Then poor air quality will be due to pollutants trapped above the city. Then heat islands, their temperatures are rising due to heat being trapped above the city. So all this could result into those factors mentioned. Okay. 1.5.5, air pollution reduces the amount of a city's clean air at night. Explain this statement. 155. I could say that at night, there is less air blowing into the city to clean up pollutants. To clean up the pollutants. So we would as well say that at night there is too much pollution taking place. Also, you could say the pollution dome is situated close to the city. Is situated close to the city, among other factors. Okay, 1.5.6 provided two sustainable strategies that can be implemented in cities to minimize the effects of industries on pollution dome. Okay, to minimize, I think we have space here. We could say put fines to industries that do not respect regulations on pollution. So I could say to carry out decentralization or industrial decentralization. Industrial decentralization, so that industries are moved away to other areas. Again, okay, technology. Excuse me. Install filters in chimneys. Reduce on pollutants as well. Could say. Enforce programs. Regarding dangers of pollution. As well say, advise industries to set up green belts so that they can consume most of the pollution. Also, promote greener energy sources. So, among others, so this could help in minimizing the effects of industries on pollution down. Let us proceed to question 2, which is geomorphology, by either saying, they say refer to read the following statements and choose the appropriate words in the bracket that will make the statement true. Okay. An increase in rainfall in the middle course of the river valley will result in increased, because we know in the middle course of the river valley, usually there is more of lateral erosion. So I could say there will be more lateral erosion. But as well, even vertical erosion could as well be a correct answer, because we know the more the rainfall, the stronger the river, increasing its vertical and lateral erosion. So both options could be correct. 2.1.2, the amount of load that a river can carry is determined by its gradient. Remember, the gradient refer to the steepness or the gentleness. So the steeper the gradient, for example, like this, so the river will be able to carry lots of sediment from upper course down to the lower course due to the steepness of the gradient. So 2.1.3, the volume stroke velocity of water is higher in the upper course than in the middle course. So I think we are going to say that the volume, that is the amount of water, and we know it is less in the upper course. So this goes with velocity or the speed. So the velocity of water is higher in the upper course than in the middle course. Like, because we know that the upper course, that's where it is very steep. So if water is flowing over a steeper gradient, its velocity is very high, meaning water will be flowing so fast. 2.1.4, The V-shaped valley in the upper course of a river is a result of vertical erosion, because we know when they say the V shape, they are referring to this. See, and this is caused when the river is eroding, going downwards. When it goes downwards or vertically downwards, so it's going to result into the V shape. So that's why we say that will be due to vertical erosion. 2.1.5, at the mouth of a river, there is more deposition, which results in the formation of a delta. So what is a delta? Delta is a landform which develops due to deposition at the river's mouth. Okay. 2.1.6, lateral stroke vertical erosion in the middle course results in the migration of a meander downstream. We know that meanders cannot form because of vertical erosion. So instead, they'll form as a result of lateral erosion, because it means the river is winding side to side. 2.1.7, rejuvenation closer to the source of the river will result in more erosion stroke deposition in the lower course. So remember, rejuvenation is all about the river gaining energy. Therefore, there'll be more erosion in the lower course. So it means it will start eroding the channel vertically after gaining strength due to more water, or due to gaining more energy. Okay, let's proceed to question 2.2, which says below and refer to figure below and choose the correct letter that matches the description. Okay, so 2.2.1, it says drainage pattern that formed from rivers flowing into a depression or a lake. Okay, that's going to be F. As you can see, the streams are all flowing to one central point. Okay, we need to be careful between this one and this one here. Yeah, with this one here, they are showing, as you can see, the streams are flowing out. Look at this tributary joining, then it continues like that. Then here you can see tributaries are joining like this, and the river, they continue. They come, they join, then continue. They come, they join, then it flows. So they are flowing to the one central point. That's why 2.2.1 will be F. A drainage pattern formed from rocks of uniform resistance. We know that's going to be dendritic, which could be typical of A, because it looks like dendritic. Even I think it's not dendritic. Take A, as well take C. So, but the most appropriate one will be A. Okay. Two point 2.3, drainage pattern commonly found in melting ice regions. I think that is typical of G, which is the drained, because you can see with drained forms in glacial areas where streams do not have a clear pattern of flow. They are haphazard, you see. Then 2.2.4, a drainage pattern that occurs on common slope down a linear mountain. That would be C. That would be C. That would be C. Okay, 2.2.4, a pattern that occurs on a common slope down a linear pattern. Then actually, if you look at 2.2.4, let's see. Sorry, 2.2.5, a drainage pattern that develops on alternate layers of hard and soft rocks. That has to be trellis, which is B. 2.5, that would be B. Then 2.2.6, a drainage pattern that commonly forms on areas of volcanic mountains. That would be D. Areas of volcanic mountains, that would be D. Then 2.2.7, a drainage pattern formed where prominent ridges lie parallel to one another. That's to be trellis, which is B, because with trellis it looks like dendritic, though we look at the tributaries that are too short and they join the main, you see, too short. So with trellis, the tributaries are too short, which is going to be B. Oh, 2 point drainage pattern formed where prominent ridges lie parallel to one another. Let's check this question once again. So about that, this technology, okay. A pattern found where prominent ridges lie parallel to one another. That's gonna be C, which is a parallel pattern, right? Then 2.2.8, a pattern in which the main streams and their tributaries display many right angle bends. That has to be rectangular, which is E. Okay. 2.3, figure below shows a meandering river. You can see this is our meander. This is a feature here, the feature here. Okay. So what is a meander scar? So all of us know meander scar. A featured fluvial landform. Fluvial landform that forms when Oxbow Lake dries up. Okay. 2.3.2, in which stage of the river can a meander loop and a meander scar develop? I think they are more developed in the lower course. But as well, they could also give the middle course. The middle course. 2.3.3, name the slopes that will develop at X and Y of the meander loop. X and Y, so it's a bit dark, but this side is X and this side is Y. So at X will be the undercut slope. That's where the water flows so fast. So I could say X, the undercut, sometimes we call it the scarp slope. Then Y, where the river deposits materials, that would be the slip off slope. 2.3.4, at which slope X or Y will there be more deposition than erosion? because we know the slope off, that's where the river deposits more. Okay, so it means to be it should be slope y, which is the slope of slope. So that is where there will be more deposition than erosion at slope y due to slow movement of water. So the river can no longer erode. Instead, it will be depositing more materials at that point. Oh, this is a given reason for your answer. Would say there is low velocity low velocity the slope is shallow. So we talk about gradient. So all this will result into the river to deposit more materials than to erode. 2.3.6, explain how a meander scar is formed. I think when I use this space here, I would say, before we look at the meander scar, we need to understand Oxbow Lake. We say a river erodes the outer bank and deposits in the inner bank. Okay, then we say the meander neck is narrowed due to erosion which eventually breaks, is cut off, forming the Oxbow Lake. The Oxbow Lake eventually dries out, forming a meander scar. All right, let's proceed to question 2.4, which says start the figure 2.4 below on river capture. So they say define the term headward erosion. So we could define it, and we say depends when I'm gonna write it on top here. A river erodes backwards towards its source, lengthening its channel. That is headward erosion. (2.4.2) name one possible factor from figure 2.4 that could have resulted in river A capturing river B. River A, so that river A This was our captor river, which was more stronger. So they are asking us to give one factor. So you could say, so that river A, I think let me use our blank page so that I have enough space. This is for question 2.4.2. So we could say that river A was flowing on less resistant enabling it to erode easily. Or you could say river A was flowing on steeper gradient making it more energetic. Or river A had a higher velocity and strength. Or river A had more water to make it more stronger. So these are some of the factors that could have resulted in river A to capture the other river. Okay. Question 2.4.3. Explain how the process of headward erosion contributes to river capture. So 2.4.3. So you could say a river erodes backwards towards its source. The river is able to erode through the watershed and will steal the other area. So that's how you can explain how headward erosion could contribute to river capture. Okay. The next question, which is 2.4.4, give the geographical terms of features D and E, which develops from river capture. Features D and E. So you can see this is our feature D here after capturing. That's feature D there, which is curving. And all of us know a feature which curves, that you will refer to it as the elbow of capture. Feature D, elbow of capture, where capturing took place. And feature E, you can see this area which has been left dry. You can see the river continues the other side, but then this area has been left dry, and we refer to it as a dry pen or a wind gap. So feature E is going to be our wind gap or a dry pen. 2.4.5. Discuss three physical changes that will occur in River A as a result of river rejuvenation. So what's going to happen to River A? Would say its erosive power. Will increase. Its energy and velocity will increase. It will erode more vertically. It will have more volume of water. More volume of water. It will develop various landforms such as rapids, to see, among others. Right. Question 2.5 below, which is an infographic on Cascade River catchment area. Cascade River catchment area. Okay. Okay. So 2.5.1, they say define the concept river catchment area. So a catchment area, but as well define it, area that supplies my technology. Sorry about that. Okay, so I could say area I write it here at the bottom. Area that supplies a river with water. So 2.5.2, of which river is the Cascade River a tributary? Let's go check through. So of which river is the Cascade River a tributary? Okay, first. which river is Jaskai River a tributary? Okay, let's see. This is the dam on top there. There is a dam here. So this is Jaskai here. So this is an area. Chalami. So it comes, it's flowing into which other river? So here they mentioned the Crocodile River. This is Crocodile River. So which means that this tributary, the Jaskai River tributary is flowing into the Crocodile River. That's why we say the Crocodile River. Okay. 2.5.3. The water quality of Jaskai River is deteriorating. Substantiate the statement by referring to the infographic. Why is it deteriorating? Okay, let's check here. One of Hautenge's largest rivers, the Jaskai, flows northwards, meandering through bed flowing into hydrotrophic at spot dam. It's roughly 50 kilometer course through the city, inexorably marks it as a casualty of Johannesburg massive urbanization. Its ready waterways, a repository for the city's torrent of sewage, stormwater, litter, industrial waste, building rubble. Water expert Dr. Anthony, not only is the Jaskai one of the country's most polluted rivers, it is also one of the saddest. Its demise, he believes, is a metaphor for all what is wrong in our city. All right. So they say the quality of the Jaskai River is deteriorating. Substantiate the statement by referring to the infographic. Okay. I think we can focus on this point here, on this statement here. Let's talk about, so all the lot of points here. Why is water quality deteriorating? 253. Got it here. Three. Okay. Check. Testing one, two. All right, it's back. So 2.5.3. The water quality of Jaskai is deteriorating. Substantial statement by referring to the infographic. Okay, let's go back to 5.3. So remember, we had identified, they said, the torrent of sewage. So talk about sewage from industries and homes that pollute the Jaskai River. Okay, that's one. Also identified also this other part here about urbanization. check. So, excuse me, urbanization, which has also resulted into high pollution of the Jaskai River, because we know when most people are running away from rural areas to come stay in cities, so at times this also increases pollution, which does affect most of the rivers. So talk about litter, another reason. Say the Sky River has been affected due to too much litter affecting its quality, affecting its water quality. Okay, what else could we talk about here? Okay, so among other factors, let's try to check if there's some other points here. Okay, so in a paragraph 2.5.4, in a paragraph of 8 lines, suggest possible strategies that can be implemented to deal with the problems identified in question 2.5.3. What can be done? 2.5.3. It's a buffer around, excuse me, buffer around river to prevent people strict laws and regulations regarding pollution of rivers, as we'll talk about. Environmental campaigns, excuse me, environmental campaigns to educate people, get people on importance of rivers. So rivers. So talk about cleaning campaigns to ensure that rivers, excuse me, rivers are still safe. Fix sewage pipes to avoid leakage into rivers. That also, okay, that is among others. First take a glass of water, then I'll share. Okay. Question 3, geographical skills and techniques. Background, the coordinates. This was Howick is a town located in KwaZulu-Natal. The town is 1,050 meters above sea level with warm summers and cool dry winters. Snapperture descends upon Howick when snow falls on the nearby Drakensberg. The town is located along the N3 freeway, connecting it with the rest of South Africa. The town is the location of Howick Falls, which is the large waterfalls that occurs when the Omgen River falls 95 meters over the Ararat cliffs on its way to the Indian Ocean. All right. Excuse me. So they say the first question, 3.1.1, in the topographical map index 2930SC, the 29 and 30 indicate. Let's check on our Howick map. Let's try to zoom in a little bit. Okay. So this is our 2930. And as you can see, 29 shows, 29 shows a latitude and 30 shows a longitude. I know the latitudes are numbered south, longitudes increases to the east. So which means answer for this case will be 29 latitudes and the 30 longitude, which is B. Howick Waterfalls is located in which province? Remember, as we read, Howick is a town in KwaZulu-Natal, which is supposed to be A. So always for such information, do not forget always to read through those given infos or infographics. Or sometimes learners miss out on such easy questions. Okay, 3.1.3. What is the difference in height between spot height 1030 in block 3 and spot height 784? So for this case, the difference, just gonna subtract, and we say 784 subtracted from 1030. Then we get our calculator here, and we send our calculator. We say 1030 minus 7. Put it here, minus 784. So our answer will be 246 meters. 246 meters. Then 3.1.4, calculate the distance in meters between spot height 1030 and spot height 784 in block D4 on topographic map. So let's go in block E3 and block D4. The block E3, this is E1, E2, E3. So we are here. This is our spot height, which is 1030. And the D4, is it D4 or D5? Let's check. Yes, D4, which is 784 here. So which means we're going to measure from this spot height to this spot height. So what you do, you get your ruler and you measure in centimeters from the given spot to the other spot. But for this case, let us assume that we measured and let's say we got 6.2 centimeters as our distance. What do? We come here and we say 6.2 centimeters. We need to convert it to because this is the distance in meters to the scale, which will be 500 since we are using a topographic map. So 6.2 times 500, go back to our scale, 6.2 times 500, going to get 3,100 meters. Okay. Then 3.1.5, they say, use the answers in equation 3.1.3. So 3.1.3, our answer is 246 meters. And 3.1.4, our answer is 3 meters. To calculate the average gradient in meters between the two spot heights. So what we do there, since we already have the distance, this was the distance here, then this was the difference in height. Okay. Difference in height. So what we do here, as our formula states, vertical interval over horizontal equivalent. So meaning our vertical interval, that is the difference in height, which is 246 meters over the horizontal equivalent, which is the distance in meters. Okay. So when you have everything in meters, then the figure on top divides by itself, divided by 246. And what you do on top, you as well do it at the bottom here, divided by 246. Then you say 246 divided into 246, that will be 1. Don't forget that our answer for gradient must be in a ratio. So it's going to be 1. Then 3,100 divided into 246 divided by 246. So our answer is 12.6. That's our gradient. Okay. Then we proceed to 3.1.6. Choose the correct answer from the option provided below. Write only the letter A to the next to the question number. A cross-section of the slope between spot height 1013 block E3 and spot height block D4 on topographical map is a cross-section. So let's go again to those blocks. Spot height 1030 in E3 and D4. E3 and D4. So you can see that at E3, between the spot height, this area is gradual or is gentle. That's why there's even farming. But as you go to the other side, look at the contour lines here. The contour lines at this particular point, they are too close to each other, which shows a steeper gradient, right? Which means it could be something like this. Gentle, then becomes steep. Okay, let's check on our options here. So when you look at option B, you can see it is gentle, then it becomes steep. You see? That's why we're going to take number B. as our correct answer. Give a reason, then you could say at E3 shows a gentle gradient and steeper at D4. Okay. Then 3.2 refer to the valley at G in block B2 on topographic map. To the valley at G in block B2. Let's check. Sorry about that. Block B2. Okay. The valley at G. So this is where we are at G. Block B2. All right. Choose the correct answer from those given below. Write only the letter to the number. The nocturnal or nighttime wind that develops during the night in this area is called, that will be katabatic winds, because we know that katabatic winds develop in the valley at night. Explain how wind promotes the formation of dense fog at G. So let's go back to our blank page. So you could say at night, cold air subsides at the valley bottom, forming frost. The cold air at valley bottom condenses below freezing point, forming the fog. Forming a fog. Okay, so that is how the winds, that is katabatic, will result in the formation of dense fog at G. Then question C, how development of fog in this area impact early morning traffic on the secondary road? Consider this is our secondary road here, secondary road. And then they're saying that this is developed already. There's a lot of fog in this area. So how will it impact on the early morning traffic? So when there's too much fog, it reduces visibility, causing traffic to move very slow. Okay. We got question 3.2.2. Refer to the River in the south of the topographic map. South of topographic map. Let's go south. With River. Here, this is our River here. We got it. All right, so it moves all the way. This is River there. Somehow it falls there. All of this is Umgen River. Another tributary joining it there. Right. Okay. So I erase this for more visibility. Okay, so let's go back to the question. It says, in what general direction does the Umgen River flow? Let's check. So you can see that this side it is too steep, right? Too steep. And we know that rivers, they originate in steeper or from steeper areas, and they flow towards gentle places. So it means that this river was flowing, if we put our compass like this, our compass, it was coming from the northeast going to the southwest. Why do we say southwest for this case? As I mentioned before, so that the river do originate from higher areas. So this is visible by looking at the contour lines. I think you can see how contour lines are too congested here or close to each other, indicating steeper gradient. Again, the other side. But as we pass the Howick waterfalls here, as it continues this other side, you can see that the gradient becomes gentle. And also, you can see that now the meanders are more developed in this other side, which means that the river was flowing from the northeast towards the southwest. Okay. Okay. So that's why we say, that this river is flowing to the southwest direction. Write it down here. Southwest direction. Give evidence from the map to support your answer. Let's say gentle gradient in the southwest. So that is 132B. Gradient southwest. So steeper gradient in the northeast as well. You could see meanders in the southwest. Flood plains in the southwest. Let's try to check those ones for clarity. You can see we have flood plains around this other area next to the river. Remember, flood plain is a flat land or a level area across the river, and in most cases that area is used for farming. So there's a flood plain. This other side, there are meanders that are more developed also in the southwest. Then the gradient is gentle again around this other area. That's why you can even see there are a lot of buildings, farming taking place instead of this other side. Then this other side you can see the gradient is too steep as a result of these contour lines. We still have very steep here. The evidence of waterfalls that are more common in the upper coast. So which means that it can't be flowing to this other side. So it is flowing like this, going to the other direction. All right. So that is for that question. Let's proceed to question 3.2.3. Identify the stream order at H in block F4 on topographic map. Block F4. F4. So this is at H here. Let's try to zoom it. Okay, so you can see at this point, this is H here. If we draw this stream nicely, you can see the other stream, this other stream, right? It means there is 1 and 1, which will give us a 2-order stream at H. Right to back. So meaning there will be a 2-order stream. 3.2.4, landform 8 on the orthophoto map. Let's go to the orthophoto map. Okay, landform 8 on the orthophoto map. Let's check orthophoto map. Landform 8. Okay, landform 8, you can see contour lines steep on either sides. The second option is here, which could be either a spar. So it could be a spar or it could be a saddle. Identify the fluvial feature at the base of the Howick waterfalls on the orthophoto map. Orthophoto map is at 9. Yeah, that looks like a pool, because they say under the question talks about the feature at the base of the Howick waterfalls. So we know that would be a plunge pool that develops when the falls erode downwards. 3 to 6. Identify the fluvial form of which the cross section above is illustration. So this would be a meander. Name the fluvial process taking place at 10 and 11. So at 10, it will be deposition, because that is the slip off. Then at 11, it will be erosion, because that is an undercut. In 331, GIS, refer to block B1. Vector data is data that consists of points, lines, and polygons. Identify the following vector data in block B1 that relates to conservation. A point feature, block B1, that relates to conservation. This is B1 here. So I need to identify a point feature in block B1 that relates to, okay, let's see. our map. Is that clear? Let's try to zoom in and see. In P1, what do we see here? What feature? Yeah, based on our map here, I think because of the resolution, you can't easily see the lookout, identify a point feature there. But let's try a polygon. So a polygon is a polygon that could be woodland. See, all of woodland that is in block B1, which is woodland. Then refer to the Howick waterfalls in block E2. So they say the location of the Howick Falls at F in block E2 on topographic map is an example. The location that is going to be spatial data, because we know spatial data deals with the location of objects. So since they spoke about the location of the Howick Falls, that would be spatial data. Then 3.3 refer to Mgen River, which run through the town of Kwa Mevena in block E1. Define the term buffering. This is drawing rings around a feature or demarcating a zone around a feature. Demarcating a zone around a feature, that is buffering. So number B, do you think buffering was applied in the development of the town in block E1? Let's go and check. Block E1. Do you think buffering was applied in development? That's the question. Development of the town in block E1. Do you think buffering was applied here? We could say so, because at least the river is still being preserved. Otherwise, there will be no river there. Okay. But as well, I think let's go with a no, because let's say no, buffering was not applied. Give a reason. The town encroaches encroaches on the river. Town encroaches on the river.